The very first thing you'll need to do to implement a particle filter is initialize all your particles. You'll have to decide how many particles you want to use. This parameter is mostly decided empirically, but theoretically, the particle filter will exactly represent the Bayesian posterior distribution as the number of particles approaches infinity. If you have too few particles, you will not have enough to cover all of the high likelihood positions, so you might miss the correct position. For instance, if each cell in this grid is equally likely to be the car's position, and you only have 3 particles, you wouldn't have enough particles right now to represent this. However, having too many particles will slow down your filter and prevent it from localizing a self-driving car in real time. There are 2 main ways you can initialize your particles. The first is to sample uniformly across the state space. For instance, you could divide the state space into a grid and put 1 particle in each cell. However, this approach is not very practical if the state space is too large, such as in the case of a self-driving car, where the state space spans essentially the entire land surface of the Earth. The second approach for initialization is to sample around some kind of initial estimate. For a self-driving car, this initial estimate can come from a global positioning system, or GPS. If you remember from the very beginning of the localization module, you cannot rely on GPS alone for localization because of its low accuracy and reduced availability in certain environments. However, GPS can be very useful to provide an initial rough estimate of your location. For your implementation in the particle filter project, I want you to initialize your particle filter by sampling from a Gaussian distribution, taking into account Gaussian sensor noise around the initial GPS position estimate and the initial heading estimate. Now, I want you to practice doing this in C++ by using the C++ standard library normal distribution function to sample positions around a GPS measurement.